This video is about comparison of arithmetic sequence and a geometrical sequence. For arithmetic sequence, the definition is the difference of any term and its previous term is a constant. Then the sequence is called arithmetic sequence. This D is a common difference. When you prove whether a sequence is an arithmetic sequence, you got to use this formula to prove. For geometric sequence, the ratio of any term and its previous term in the sequence is a constant. Then the sequence is called the geometric sequence. These are called the common ratio. When you prove whether a sequence is a geometric sequence, you got to use this formula to prove. You can figure out this common difference. Use the second term minus the first term, or you can use the 20 terms minus 19th term. Same thing for the geometrical sequence. The common ratio equals usable 2 over usable 1 or usable 20 over usable 19. The general form for arithmetic sequence is usable n equals usable 1 plus n minus 1 times d. For example, I can write down usable 9 equals usable 1 plus 8 times d, or usable 100 equals usable 1 plus 99 times d. For geometric sequence, usable n equals usable 1 times r to the n minus 1th power. For usable 9, I can write down usable 1 times r to the 8th power. For usable 100, I can write down usable 1 times r to the 99th power. Arithmetic sequence is a linear function with a natural number as a domain. So for this x will be a natural number. Then this will be the arithmetic sequence. For geometric sequence, it's an exponential function with a natural number as a domain. When this x is a natural number, this will be the geometric sequence. The common difference will be the slope. The common ratio will be the base. So for the sigma notation, when you say this linear function, then this will be arithmetic series. The d is the slope. The number of terms will be this q subtract this p plus 1. Don't forget plus 1. From this sigma notation, we know the starting ordinal number is p. How to get the usable 1? When k equals p, we plug in p for k. We will get m times p plus b. This will be the usable 1. Then you can use this formula to figure out the summation of this sigma notation. For example, first of all, we know this is a linear function, so it's an arithmetic series. The common difference is a slope 2. Then the number of terms will be 10 minus 4 plus 1 equals 7. And then the first term, the starting ordinal number is 4. So the first term will be 2 times 4 minus 5 equals 3. Then s sub 7, altogether 7 terms, equals 7 over 2. 2 times 3. Then plus n minus 1 is 6 times d is 2. 12 plus 6 is 18. So you will get 63. For geometric sequence, sum of a times b to the kth power as k goes from p to q. P is the starting ordinal number. The common ratio will be the base b. Number of the terms will be q minus p plus 1. When k equals a starting ordinal number p, then a times b to the pth power will be the first term. You can use this formula to figure out this sum. Let's go to example. Sum of 3 times 1/2 to the k minus 1's power as k goes from 2 to 5. For this function, 3 times 1/2 to the k minus 1's power is a times b to the x power form. This is a geometric sequence. For this geometric sequence, the common ratio is the base 1 over 2. Number of terms will be 5 minus 2 plus 1 equals 4. The first term will be the starting term of this summation. That is 3 times 1 over 2 to the 2 minus 1's power. That equals 3 over 2. S sub 4 equals U sub 1 is 3 over 2. 1 minus 1 over 2 to the 4th power over 1 minus 1 over 2. Answer will be 45 over 16. The formula for arithmetic series is this one and this one. There are two formulas for geometric series. You can use either one. You will get the same answer. Also for geometric series, we have the formula for the sum of the infinite geometric series. When the absolute value of common ratio less than 1, S sub infinity equals U sub 1 over 1 minus R. Remember, only when the absolute value of ratio less than 1, which means only the common ratio greater than -1 less than 1, we will use this formula. When absolute value of R less than 1, the geometric sequence converges, which means the limit of U sub n as n approaches infinity exists. Let me give you an example about the sum of infinite geometric series. Consider the infinite geometric series 1 plus 3x over 4 squared plus 3x over 4 to the 3rd power, and so on. For what value of x does the series converge? We know only when the absolute value of common ratio less than 1, the geometric series converge. The absolute value of R less than 1, we know that's the R greater than -1 and less than 1. So from this given geometric series, we know the common ratio equals 3x over 4. So we set up 3x over 4 greater than -1 less than 1. How to solve these compound inequalities? We will multiply by 4 for every single term. You will get the 3x less than 4 greater than -4. divided by 3 for every single term, you will get x is less than 4 over 3 greater than negative 4 over 3. So when x is greater than negative 4 over 3 and less than positive 4 over 3, the series converge. Let's go to B. Find the sum of the series if x equals 1.3. We will figure out R first. 3 times 1.3 over 4. That equals 3.9 over 4. That equals 39 over 40. Since the series converge, we know the S sub infinity equals, the first term is 1 over 1 minus R equals 1 minus 39 over 40 equals 1 over 40. Jump up equals 40. Let's talk about the relationship between U sub n and S sub n. The first term, U sub 1, equals S sub 1. And the second term equals S sub 2 minus S sub 1. And U sub n equals S sub n minus S sub n minus 1. We do know the D equals U sub n minus U sub n minus 1 for arithmetic sequence. For geometric sequence, this is all the same. And U sub n over U sub n minus 1 equals R. Let's look at one example. The sum of the first n terms of a sequence is given by S sub n equals 3n squared plus n, where n is all positive integers. Find S sub 4, S sub 5, and hence U sub 5. For S sub 4, we will change every single n in this formula into 4. So 3 times 4 squared plus 4 equals 52. For S sub 5 equals 3 times 5 squared plus 5. That equals 80. Then U sub 5 equals S sub 5 minus S sub 4 equals 80 minus 52. That equals 28. For B, find the U sub n. Because U sub n equals S sub n minus S sub n minus 1. I'll show you the reason why we have this formula. We know S sub n equals U sub 1 plus U sub 2 plus U sub n minus 1 plus U sub n. And S sub n minus 1 equals U sub 1 plus U sub 2 until U sub n minus 1. Then I subtract. We will get S sub n minus S sub n minus 1 equals U sub n. Because we cancel U sub 1 to U sub n minus 1. So we get this formula for U sub n. For S sub n equals 3n squared plus n. For S sub n minus 1 equals 3 times n minus 1 squared plus n minus 1. So we have 3 times n squared minus 2n plus 1 plus n minus 1. Distributive property 3n squared minus 6n plus 3 plus n minus 1 equals 3n squared minus 5n plus 2. Then for the u sub n, I will use s sub n minus s sub n minus 1. That equals 3n squared plus n minus 3n squared minus 5n plus 2. Don't forget here is a parenthesis. So you can do the distributive property here. 3n squared plus n minus 3n squared plus 5n minus 2 equals 6n minus 2. U sub n equals 6n minus 2. For the C, show that it's an arithmetic sequence. We got to use this formula. Common difference equals u sub n minus u sub n minus 1. So we got u sub n equals 6n minus 2. U sub n minus 1. We will change n into n minus 1 minus 2. That equals 6n minus 8. So u sub n minus u sub n minus 1 equals 6n minus 2 minus 6n minus 8. That equals 6. This is a constant d. So it's a arithmetic sequence. Let's talk about consecutive arithmetic sequence and consecutive geometric sequence. For ABC, suppose this is a consecutive arithmetic sequence. We do know B minus A equals C minus B. That equals a constant number D. Let's working on B minus A equals C minus B. Add B both sides, we will get the 2B minus A equals C. 2B equals C plus A. This is a very important formula for consecutive arithmetic sequence. If we divide it by 2, we will get the B equals C plus A over 2. This is the second very important formula for consecutive arithmetic sequence. For consecutive geometric sequence, we do know A over B equals C over B equals common ratio R. Cross multiply B squared equals A times C. This is the first formula for consecutive geometric sequence. If we do square root both sides, B equals plus or minus square root A times C. The second formula for consecutive geometric sequence. Let's go to example. The three terms A, 1B are in arithmetic progression. The three terms 1AB are in geometric progression, which means a consecutive geometric sequence. Find the value of A and of B given that A is not equal to B. For the arithmetic sequence, we have A, 1, and a B. So we get 2 times 1 equals A plus B. For geometric sequence 1AB, we know A squared equals 1 times B. So we get these two equations. We need to solve this system of equations. A plus B equals 2. Here is B equals A squared. We plug B equals A squared into this equation. We will get A plus A squared equals 2. Since this is a quadratic equation equal to 0 form, A squared plus A minus 2 equals 0. Factor A plus 2 times A minus 1 equals 0. So A1 equals -2 and A2 equals 1. Then for B1 equals -2 squared equals 4. For B2 equals 1 squared equals 1. Since A is not equal to B, so we cross out this B2 and A2. We only get the A equals -2, B equals 4. Then we plug back in, check whether A1, B form this arithmetic progression. A is -2, 1, and 4. So we could see the difference will be 3. For 1AB, we will have 1, -2, and 4. So the common ratio will be -2. So this is the final answer. A equals -2 and B equals 4. When you see the word increased by the same amount, or decreased or reduced by the same amount C, then this is an arithmetic sequence and a series. For increase by the same amount C, the common difference equals C. For decrease or reduce by the same amount C, the common difference equals -C. When you see the following words, it will be geometric sequence and a series. 8% of the previous one. Common ratio equals 8%. C times the previous one. Common ratio equals this C. Increase by 8%. Then common ratio equals 1 plus 8%. Decrease or reduce by 8%. Common ratio R equals 1 minus 8%.